Hello, I am Takeshi Honma. I'm gonna present about our paper, Unsupervised Domain Adaptation on Question Answering System with Conversation Data. In our research, we're gonna tackle on the problem of conversation question answering in machine reading comprehension. The task is the immersion model receives conversation history and documents. From that, the immersion model finds answer span to the last user's question from the documents. In this example, the user finally asks the question, my printer goes offline, what to do? Then the immersion model tries to find the answer from the documents. Then if it successfully gets the answer, it outputs as an answer from the system. Uh, Also, there are many research achievements in the unsupervised immersive domain adaptations. They assume that they first train the immersive model in source domain, where the full set of training data are available. It means that conversation and document and answer spans are available in the training data. Then they're gonna transfer the model in the another target domain. But in the target domain, they assume that the limited kinds of data are available. It means only the conversation and documents are available, but answer spans are not available. In addition, in our situation, we can adapt immersion model to the target domain when only the conversations in the target domains are available. Why we think of such a situation? That is, we we face on the lot of situation where the human talks with humans. Then in this conversation, it contains a lot of knowledge. So we can extract the knowledge from the conversations. Then by using the knowledge, we want to adapt the immersion model. So that is our setting. To realize the domain adaptation in our setting, we propose the method as follows. Our method is consisting of document generation and self-learning. First, we assume that conversations are available in target domain. From that, we can convert the conversation to the document by using document generator. This generator is made by using a sequence-to-sequence model based on transformer architecture. Once we get a document by using immersion model trained in the source domain, we're gonna do the inference, then make a pseudo label. It means the answer spans. So these answer spans are not proven that all the answer spans are correct. So we're gonna pick up only the high confidence answer span. Then by using these, we can train the immersion model starting from the immersion model trained in the source domain. So we're gonna call this process self-learning. In addition, we're gonna introduce discriminative learning. This figure shows regular immersion model training. The conversation and documents are input, and the model outputs the predicted answer spans. Also, the comparing with the ground truth answer span, it calculates a loss. Then adjust parameters of the immersion model to minimize the loss. So in the internal of the immersion model, we actually use a transformer-based raw data model to construct the immersion model. By picking up some hidden values, we can make a discriminator. The task of a discriminator is judge whether the input conversation documents are belonging to source domain or target domain. By minimizing the loss function calculated by comparing predicted domain and ground truth domain, the discriminated training stage itself enables the model to learn the difference in the feature distributions between source domain and target domain. To evaluate our method, we use doc2dial dataset. This dataset is consisting of documents and conversations where the user asked questions to the expert. Also, the expert's answers in the conversation are grounded to the documents. The dataset has 4 domains, so we use one domain as a source domain, and also that we tested our method when the model is adapted to the other 3 domains. The performance of the MRC is calculated by using word-based F1 score between predicted answers and ground truth answer. The table shows the result. When no adaptations is used, the performance is around 50%. By using the adaptation techniques, that is document generation and self-learning, it improves performance. Finally, by using discriminative learning, it improves more. To conclude, our method works well, but the improvement is still small. So how to improve the performance is our future work. This is a summary of our work. Also, our future work is to investigate how to improve MRC performance more. The one candidate is to use adversarial learning idea in the domain adaptations. Thank you for listening.